We're going to look at examples 1 and 2 in your section 3.1 notes. To solve trig identities, it's very important to get full credit for these, to start with one side of the equation, and then you're going to work, right, to transform using the identities we've learned back in chapter 1 to get to the other side. Make sure that you use equal signs as you transition from line to line. Okay. All right, so in this first problem here, we have a variety of tangent, secant, and sine, and we're trying to get to tangent squared. So one strategy is to change everything to sines and cosines. So that's what we're going to do. So I'm going to go ahead and start with the left side. Looks a little bit more complicated, more that I can do there. Okay, and then my goal is to get to tangent squared x. So sometimes I write that at the bottom just to kind of keep in mind where I'm going, okay? All right, so we could leave this tangent x alone because the bottom line is we're trying to change this part into another tangent. So I'm gonna go ahead and do that. Okay, we know that the reciprocal of secant is 1 over the cosine. And then sine we're going to leave alone, okay? All right, that's good news for us because this we can go ahead and multiply and get sine over cosine. Okay, now this is a quotient identity from chapter 1, so we know that sine x over cosine x is tangent x. And that does it, because when we multiply tangent by tangent, we will get tangent squared. Okay, so we've solved that first, or verified that first identity. Okay, all right, in example 2, sometimes it's easiest to look at the more complicated side. Here it looks like the right side, and we're gonna try to get to this left side. So I'm gonna go ahead and write this. Okay, kind of the same thing. I'm going to go ahead and put my answer down at the bottom just so I keep in mind where I'm going. Okay. All right, so I don't need to change to sines and cosines. Everything on both sides is in terms of sines and cosines this time, but I can definitely see that I need to separate out the fraction. Okay, so I'm going to go ahead and do that. So I'm going to have cosine x, and I put that over the denominator of sine x cosine x. Then I'm going to have plus 3 sine x over that same denominator of sine x cosine x. Okay, that is very good news for us because we can see some canceling happening. Okay, the cosines will cancel here, the sines will cancel here, and that leads us to our answer.